Welcome to Session 12, the finale. You've built every tool this topic requires: substitution, the discriminant, structure and symmetry, parameters, circles, radicals, the difference function, and a strategy for the digital test. Today, we don't add anything new. Today, we make it usable under pressure. Because here's the uncomfortable truth about the SAT. Most students who miss these questions don't miss them because they lack a technique. They miss them because they picked the wrong one, or because they answered a slightly different question than the one on the screen. So, let's build the protocol that prevents that. Here is your 6-step protocol. Follow it on every nonlinear system, every time. 1. Classify the system. What am I looking at? A line and a parabola? A line and a circle? A radical? 2 nonlinear equations? Naming it tells you which tools are even relevant. 2. Read the target. What exactly is being asked? A coordinate? A count? A parameter? A sum? An interval? Underline it. This is the step that saves the most points. 3. Choose the shortest method. Substitute, eliminate, use structure, check the discriminant or graph. 4. Solve accurately. Parentheses, signs, and both square roots. 5. Finish the answer. Back substitute for missing coordinates. Apply domain restrictions. 6. Verify. Check your candidates in both original equations. Classify, read, choose, solve, finish, verify. 6 steps, and they're the difference between knowing the math and scoring the math. Let's run the protocol on a genuinely hard one. The circle x squared plus y squared equals 4 and the line y equals x plus k are tangent. Find k. Step 1. Classify. Line and circle with a parameter. Step 2. Read the target. They want k, not a point. Step 3. Choose. Tangent means we could substitute and set the discriminant to 0, but Session 7 gave us something faster: the distance method. The center is the origin, and the radius is 2. Remember, the equation says 4, so r is 2. Rewrite the line in standard form. X minus y plus k equals 0. The distance from the origin is the absolute value of k over the square root of 1 plus 1, so over root 2. Tangency means that distance equals the radius. Absolute value of k over root 2 equals 2. So the absolute value of k is 2 root 2, which means k equals plus or minus 2 root 2. 2 answers, because there's a tangent line on each side of the circle. Notice we never formed a quadratic. The right tool turned a long problem into 3 lines. Here's another hard shape that shows up in your practice set. The roots of x squared plus p minus 4 times x plus 9 equals 0 differ by 6. Find p. The key fact, and this one is worth memorizing, is that for a monic quadratic, one where the leading coefficient is 1, the square of the difference between the roots equals the discriminant. So if the roots differ by 6, then 6 squared, which is 36, equals d. Now compute d from the coefficients. b is p minus 4, and c is 9. So d is p minus 4 squared minus 4 times 1 times 9, which is p minus 4 squared minus 36. Set that equal to 36. P minus 4 squared minus 36 equals 36. So p minus 4 squared equals 72. Take the square root of both sides with a plus or minus, so p minus 4 equals plus or minus root 72. Root 72 simplifies. 72 is 36 times 2, so it's 6 root 2. Therefore p equals 4 plus or minus 6 root 2. Look at everything that came together there: the root difference identity, the discriminant, radical simplification, and the plus or minus. That's a Session 12 question. Now let's talk about how you practice, because this determines whether the next month improves your score or wastes it. When you miss a question, do not just rework it and move on. That teaches you almost nothing. Instead, label the error with one of 4 categories. Setup: you built the wrong equations or substituted the wrong thing. The math was fine, the model was wrong. Algebra: a sign, an expansion, a factoring slip, a formula misremembered. You knew what to do and did it wrong. Completeness: you found a real answer but not the whole answer. You lost a negative root. You gave x when they asked for y. You found one coordinate instead of the pair. Validity: you accepted something you shouldn't have, an extraneous root, a negative width, an undefined value. Now here's why the labels matter. Each category has a different fix. Setup errors mean slow down and translate more carefully. Algebra errors mean write more steps. Completeness errors mean reread the question before circling. Validity errors mean check the domain. Count your categories over 20 missed problems, and your weakest one will be obvious. That's the thing to drill. During a hard question, when the clock is running and you feel stuck, ask these 5 questions. 1. What does the question actually request? Reread the last line. 2. Can I avoid finding the full coordinates? Often a sum, a product, or a count is all they want. 3. Is there a repeated expression or a factorable structure? Difference of squares, a repeated x squared, a perfect square trinomial. 4. Would the discriminant, the eta, or a graph get there faster than what I'm currently doing? 5. What restrictions must I check? Domain, sign, context. Those 5 questions take about 10 seconds, and they will rescue you from most dead ends. And if you're 90 seconds in with no progress, mark it and move on. An unanswered easy question later costs exactly as much as this one, and it's cheaper to get it right. Let's do a final one from your practice set. The circle x squared plus y squared equals 4, and the line y equals x plus k are tangent. What is k? Protocol. Classify. Line and circle, parameter, tangency. Target. K. Method. The distance from center to line equals the radius. The radius is 2. The equation shows 4, and 4 is r squared. The line in standard form is x minus y plus k equals 0. So the distance from the origin is the absolute value of k over root 2. Set it equal to 2. Absolute value of k over root 2 equals 2. So absolute value of k is 2 root 2. Therefore k equals plus or minus 2 root 2. The answer is A. And look at the traps. Choice B, plus or minus 2, is what you get if you forget the root 2 from the distance formula. Choice C, 4, is the radius squared, the number from the equation handed back to you. Every distractor is a specific, predictable slip. Before you go, here's your mastery checklist. Be honest with yourself on each one. Can I tell a repeated root from 2 distinct roots and say what each means graphically? Can I use the discriminant without solving the whole quadratic? Do I remember that x squared equals a gives x equals plus or minus root a? Can I identify and reject extraneous and contextually impossible answers? Can I explain what each algebraic solution means on a graph? If any of those made you hesitate, you know exactly which session to revisit. That hesitation is information. It's not a failure. One last thought, and it's the most important thing I'll say in this course. Almost every error on nonlinear systems happens after the hard part is over. Think about that. You do the clever substitution, you handle the algebra, you find the roots, and then you circle the x value when they asked for y. Or you forget the negative, or you keep an extraneous root, or you give a length of -8. The mathematics was already correct. The point was lost in the last 5 seconds. So build this habit. When you think you're finished, you're not. Reread the question, check the restrictions, and confirm you're answering what was asked. Reserve that time deliberately. It's the highest return, 5 seconds, on the entire test. That's the course, 12 sessions, and you've gone from what does nonlinear even mean to solving tangency problems with radicals in the answer. Go work the practice sets, keep your error log honest, and trust the protocol. You've got this, and I mean that. Good luck on test day.